Hello and welcome to my channel. I am BeardedDev. In this video we're going to be looking at how to update data using joins in SQL. We're going to be covering updating data based on a join, updating multiple columns in the same statement, updating data based on table expressions, and in this video I'm going to be using CTEs, so make sure you stay tuned for that. And then finally some sanity checks we can carry out before we update data in a live database. Now, if you do appreciate videos on data engineering or data analysis, subscribe to the channel, and if you do enjoy the video, hit that thumbs up button and comment down below your thoughts and if you found this video helpful. As always, if you would like to follow along with the video, the statements are available in the description at the bottom. And we're just going to be simulating a simple product price increase process within our database today. So we have our product table that contains a few columns along with the price. So products we're selling and the current price we're selling those products at. So we're going to be creating that table and inserting data there. And then we're going to be, like I say, simulating a process where we load data into a product staging table, perhaps on a daily basis, depending on how often our prices change and how often they need to be updated. And we're going to be using that data to update our data in the pricing table. So our product table doesn't store history. This is just a sort of a back-end application database that just stores the product price as it is currently. We could look at doing future videos on how to write history to another table, perhaps some auditing of what changes we've actually made. So let's dive right in. Okay, so we've got a couple of tables now created with data. We've got 8 products. Typically we'd probably have a lot more. We have a code that uniquely identifies our product, which is what we're going to be basing the join on. We have a name, category and our price as it's stored in the product table. Then we're going to be picking up data from our product staging table, and this does include pricing for all products, so we'll have a look at that shortly. But we can see a simple example of our laptop. There's going to be a price increase there of £40. So let's start off with having a look at how we can join data. So the key is we need an identifier column, and in this case we've got our code. So I'm just going to alias our product table as TGT, which just shorthand for target. Common methodology within sort of working with data. We have our source and we have our target. So our product table is going to be our target, and then we're going to inner join our product staging table, and we're going to alias that as src for source. And like I say, we have the identifier between the two tables as code. So we're going to join on target code equals src code. And if we have a look at now combining those tables, I'll just comment this query out for now. This gives us an idea of when we're looking at the data in the same row, we can see that there's going to be some price increases. Now, top tip, when updating tables, we could have hundreds, thousands or even up to millions, billions of rows in this table. The amount we can store is really endless with storage these days. So the top tip is really just to limit the amount of rows we were updating. So if you think about it, if we were to write an update statement now, we'd update 8 rows every time. But we only really want to update rows where there is a price difference. So we're going to add a where clause to say where target price is simply not equal to our source price. And that's going to limit our update statement, the amount of transactions we're carrying out. Also limits the amount of logging that has to be done. So we've got our select, and then we're simply going to change it to an update. Key aspect of working with updates based on joins is we must have a good understanding of our aliases. So from clause is evaluated first. That means we've changed our product table to our target table, and we've changed our product staging to SRC. So if we was to write out our update to say update product set product dot price equals product staging dot price, and we're going to be updating multiple columns, and within our set we can just put a comma separated list. So in this case we're going to be updating our product modified date to current timestamp. And if we was to try and have a look at running that, we will get messages about identifiers that we can't be bound. In other words, SQL engine doesn't know what table that's coming from, and typically because we would have column names that exist in the same table, we might even get some ambiguity errors as well. So if I was to set like price equals price, and if we try and run that, we'd get an ambiguous column name. So in other words, the database engine doesn't understand what we're actually trying to do. So in this case we're going to be updating TGT. That's what we've aliased our product table as. So we're going to be setting our TGT.price equals our SRC.price and our TGT.modified date. And notice that isn't actually coming from our product staging table. We're just setting this to the timestamp within the database engine of when we actually perform this update. So it's quite straightforward to do. Key thing is we could write out our join as normal, but aliases do play a major part within an update. So we could go ahead and run that. We know we've got 4 rows where we've got a different price, so we can see 4 rows have been affected. And if we now change this and have a look at that product table, we know our laptop price was expected to increase to 439.99, but the good thing about having this condition in here is where we check that the price is different. If we was to simply run the update again, we wouldn't expect any rows to change because we haven't made any changes to the product staging table. So I've run that again and we can see that 0 rows have actually been affected. I'll just comment this back out for now, hide the results. Now typically we want to check that results are going to be produced as we expect them before we run these kind of queries. So I'm just going to reset the tables for now so we will see an actual difference. So typically we might see an approach where we'd start with our select to see what's going to change. So we'll just start with a select all, and if we run that we can see these 4 rows are going to change. We're happy with that, and then we'd comment out this, we'd comment in our update, and then we'd run our statement. Now one approach we could look at is using CTEs for this. It can be quite cumbersome. We need to comment things out, comment things in, so we could use CTEs for that approach. So let's have a look at how we would do that. So let's remove our update for now, and we're going to wrap our select within a CTE. So let's say with CTE as, and the key thing here is the columns. We've got multiple columns called the same name, such as code, that exist in both tables, and we're going to have to alias those within the CTE. So I'm just going to simply put TGT underscore the column name followed by source. So I'm just going to quickly write those out. Name, you'll notice I have put in square brackets or square parentheses, and that is simply because it is recognised as a keyword in SQL. So we've got category, we've got our target price, so again TGT underscore price. We will include date stamps as well, because we are using our date stamps to verify that some rows have actually been changed. So we could write a query after our update to say select all when modified date is greater than the beginning of today or a few hours ago, or whenever we ran the query. And then we can include source columns as well. So again, it's just going to be src underscore the column name, which in this case is name, src underscore name, src dot category as src category, and lastly the price. Okay, we're going to leave our where clause in, remove the results grid for now. I'm just going to indent within the CTE. If you've ever watched my videos before, you know how pedantic I can be with things within parentheses indented to make it a bit more clearer. So if I have a look at that, we've got the same results, but what we can actually do now is just perform the update on the CTE. So we've got our select, so if we ever wanted to check, we could just run this select and we can have a look at what's going to change. But now we can simply actually perform an update on the CTE. So I'm going to write out update CTE. I'm going to be setting our TGT price, and that's going to equal our SRC price, so our new column names. I'm going to set our TGT modified date equals our current timestamp. And we can see, I'm just going to uncomment this to see the results at the end. We can see again we're expecting our laptop price to change to 4399. Execute the query, have a look at the results, and again that's been executed. And at this point we can simply check this in a query and we can see there's actually no results. So there's nothing else that needs to be updated, that's been completed. A very important point to remember though is when working with CTEs, the CTE doesn't actually have any data, it doesn't store any data within the database, it only exists for the duration of the query. So whenever we're updating a CTE or performing any DML, so anything insert, update or delete, when we're doing that against the CTE, the database engine is clever enough to understand what we're trying to do, and it goes back to make those changes to the underlying table. So it's not that it's been updated within the CTE, it's been updated in the underlying table that the CTE is returning data from. So that's an important distinction. You've not changed the CTE, you've changed the underlying data in the database, and then the CTE is pulling that data from there. So there's no changes to the CTE actually happening, even though we're writing out update CTE in this row, in this case. Now the last thing I wanted to move on to is some sanity checks regarding update statements. So again, updates are permanent once they're committed, the changes have happened, so it's important to get this right. So one of the things we could do is we've talked about our identifier being code. So one thing we could put in as a check is if we have a look at our product staging table, which again stores all of our products, even though there might only be some price changes against some of those. So perhaps we could have a look at that process to only send in changes. That could be something we could sort out within that operation. Now, one thing with our identifier is we want to make sure that we only have one value per code. So we could put in a simple check ahead of our update statement to say, right, select code, and then we could group by code, and then we want to having count greater than 1. So this is a very simple check to say, have we got any duplicates, or maybe we've got codes in there that are different prices, and we would expect no results, because although that's a unique identifier within our product table, it perhaps won't be within our staging table, so we need to verify that that is unique and we only have one value. But let's take a look if we didn't have that in place, if there was other values. So again, let's update our original table, and into the product staging I'm just going to add another price for our laptop we've been looking at in detail. And now if I have my sense check query here, and we could even build on this a bit further, to pass this into a variable, have some if logic within the, if we had this within a stored procedure, say, to say check this table, if this is good, doesn't return any rows, don't run this, sorry, do run the update. If it's not, then we can send a message back to the caller to say there's an issue here, something needs to be resolved. So we can see that that is actually present in the table more than once now. And if we go back to our select within our CTE, we can see we've got 5 rows now. And if we have a look at the top row and the bottom row, they both have the same target code, and they're going to be changed to 2 different prices. So what would happen in that scenario? Well, if we keep running, if we run the CTE, so we don't get an error, we've got an update, and if we look at this code, we've got the price of 4399.99. Okay, and what would happen if we ran that again? Say, so let's imagine this is within a stored procedure that we run once a day. And if you would like to see if I'm talking about things you're not sure of, please do let me know in the comments, and I'll be happy to put some videos up explaining in more detail what I mean. If I execute that, we can see the price has now changed to 479. If I execute it again, imagine this is running daily, so we're in a situation where it's going through a loop of changing the price every time. And that's because if we look at our where clause, we can see every time we run it, we're still going to get that one row, because it's going to compare the price, it's going to do the join, and it's going to compare the price, and whatever it's been changed to, there'll always be a different row. Now, interestingly enough, if we take out the where clause and we keep executing it, remember before how the price changed. So the where clause is in there to limit the amount of rows we're changing. So at the moment it's 439.99, and if we keep running it without the where clause, it's not changing, it's still staying the same. Now, this is what could be called a false positive. So it's where something appears to be working well but is not actually working. So whether that showed 439.99 or 479, I think the other price was, it would be correct. It's just that the database engine is working that way to set it the price. Now we're giving the database engine a choice. We're saying choose one of these prices. I've set 2 for it, choose one, and whichever it chooses will be correct in terms of database processing. Now it's just coincidence, execution plans, how it's executing, that it's consistently getting the same price at the moment. Now it could be that that works for a long time, and I have experienced this in the past. Something happens, perhaps a database migration, perhaps a clearing of the cache of the execution plans or something along those lines to cause this to change, and then one day it will just appear as 479, and it's very hard to understand and backtrack exactly what's happened and why. It's one of those where it's like, I've spent days on this problem and I can't understand, but if we'd have just checked the simple things, it would have been straightforward. The other thing we can actually have a look at with updates, this is a bit of a bonus within this video. So if we were to go back to our simple, sort of without the CTE, we could do this within the CTE, but let's just go back to our original update based on a join. So if we comment that out, sorry, uncomment it, and again we'll go back to our starting position, is we could actually wrap this within a transaction. So we want to have a look at our laptop price changing. Well, we could actually start a transaction, and this is something I do occasionally, particularly for ad hoc updates. So I'm going to start a transaction, I'm going to run the update, but the data isn't actually being written to the disk until I actually commit this transaction. So I'm opening a transaction here with begin tran. I'm going to perform the update, and then I'm going to check my target table to make sure it looks as expected. Now if I wasn't happy with that, if I was getting results that perhaps didn't look right, I can then simply roll back that transaction as if nothing had happened. Notice there, it's not a way of undoing queries, it's just another sense check that we could have in there. Now the opposite of that is if we were to start a transaction again, run that update, and then have a look and think we were happy, is we can just commit that transaction. And committing is writing that to disk, so anybody querying this table in future will be able to see that that data has been updated. But we'll definitely do some more videos on transactions, so keep an eye out for those coming to the channel. Thanks a lot for watching. I hope you have enjoyed that video. Like I say, if you have, let me know in the comments below. Really appreciate it, really helps me to grow the channel.